And hello from Sydney. My name is Grant Case, and welcome back to the Proof of Concept podcast, the show where we're always trying to expose real life use cases from the field and discuss some of the hottest questions in the data science world today. I am your host, as always, and my co host up there in Singapore. Hello, Alex Hubert.
Hey Grant, how are you today?
I am doing very, very well. And today's podcast is a really interesting one. And I think we start out this question. I think we're going to bust it into two different podcasts, but this first one is really around why should I care about the fancy AI model? We've got lots of people out there building models today, whether they're doing it through a no code, a low code, or a full code aspect. But I think the question a lot of times we need to stop and ask, well, why should I care about this fancy AI model to begin with? And I guess we can always start where we always do, which is what is some of the cool stuff we can do with this AI models?
Yeah, I mean, when I was thinking about our conversation, I was obviously trying to go back to how I got myself into data science, and one day I heard about Kaggle and all the cool people, all the cool PhDs that were translating their key researches into the Kaggle community to tackle real life problem. I mean, real life, it's a Kaggle data set, right? It's not exactly real life, but still at the time, it was pretty innovative. It was pretty cool. And then the same people grew libraries like scikit-learn, and then grew library like TensorFlow, and then you had Keras, and then more and more of those cool open source libraries that help you
PyTorch
do
comes along.
PyTorch, all of those ones that help you like build all those very cool and fancy machine learning models with a couple of Python lines, and then you start to get going, right? And then from there, obviously, you have all those super cool medical application. I was reading an article the other day where finally AI and doctor are used together to detect early forms of cancer. I think it was a couple of days ago as well that DeepMind released all that catalog of proteins that they have unfolded thanks to another great algorithm that they have built. I mean, some sort of AI. So there is definitely some cool stuff happening thanks to very fancy machine learning models. That we cannot deny.
I think that, to me, when I think about, so the concept of neural networks is really from the 1950s. So this is something that's been around for quite some time. Even if we talk about convolutional neural networks in the United States, it was a form of checks, basically checking signatures and handwriting that was in the early 90s. But it really hasn't been. And I kind of look at the difference and one of the biggest moments in the quote unquote fancy AI was the release of Google Translate with the neural network. So Geoffrey Hinton out of the University of Toronto, basically Google brought him in, and that entire team just rebuilt Google Translate from the ground up. Yeah. So if you're trying to understand how to deal with different languages, neural networks, the fancy AI models was absolutely kind of this transition point. And that was in 2016. If you're interested, there's a great article from the New York Times. Wired had one at that point in time talking about that. The one thing that caught my mind when I saw that, when I read that article for the first time, was in the 10 years of Google Translate, they had made so much progress with just how better they have gotten in the translation. The Google Translate neural network basically blew out 10 years worth of hard work by a ton of Google engineers and blew it out like a lot. So for me, that key transition point is when we started to say, what can we do this? Sentiment analysis, textual understanding, all of this fun stuff that we are starting to take for granted. The whole idea of a chatbot and being able to type it's something that was, something that was crazy even seven years ago.
and it's slowly taking his space, taking place within the world of the enterprise as well. Now, indeed, in chatbot, you start to see more and more fancy models that are driving those services. Google Translate, Google Images as well.
Mhm.
My personal experience was 5 years ago, transitioning from Dropbox to Google Images, and then just being able to retrieve very quickly by places, by people, the kind of images that I
Mhm.
wanted. But that's the
Your
very
dog, like I could put in my dog's name and it pops
yeah
up and here's all
yeah
the
yeah
pictures of Arlo.
that's pretty incredible. But that's the very um, customer facing side, I would say. There is also hidden impact of AI within the enterprise. Like, how do you govern the enterprise better thanks to AI? And in particular,
Mhm.
automation of some certain reporting type of activities through AI. You can do that much quicker. And reporting can sound like, okay, it's low level, but you can, like, we're talking about deep learning stuff. I remember at that a couple of years ago, we did an amazing use cases where essentially we were making some better classification of handwritten letters for an insurance company. So they receive a ton of handwritten letters. They're paying a lot of money to send them to the right department, whether it's going to be a resiliation, whether it's going to be a claim, and stuff like that. And they realized that their accuracy wasn't that good. They built a machine learning model with us at the time that was much faster in the execution, obviously, because you don't have fatigue of the tiredness of a human to deal with, but at the same time, much more accurate. That was super cool.
Yeah. And what do you find super cool? Please follow us on LinkedIn, drop us a line on YouTube, whichever. Would love to hear kind of your feedback. What do you think is really cool? What sort of applications do you really kind of look at as being, really top notch, very interesting and understanding from you? So that brings us to, fancy AI models. You know what? Executive management loves talking about the buzzwords, but how do we explain this, Alex? How do we break down, something that actually we don't even really understand how it learns to begin with?
And then that's the crazy part, right? I remember I was never the best data scientist enough, but 4 or 5 years ago, I would understand the core concept of deep learning. Now I'm reading papers. You have all those architecture. If you don't stay close to it, you just forget about it. You just don't know what it's like. And then yeah, for executive, yeah, for sure they don't understand. So it's very important for us right now to sit down and to define what it is. And here we can take a very interesting path. Instead of defining and starting by defining what it is, let's try to define what it's not. So I'm sure that
Good
you've seen
point.
that video
Always good.
of
The counterfactual.
exactly. I'm sure you've seen that video of the dancing robot from
Yep.
Boston Dynamics. This is this is AI, yeah, potentially, but that's not what AI in the enterprise should be or what it's like. All the Black Mirror references, same in a futuristic world, maybe one day, but we're clearly not there. Anything related to general artificial intelligence, singularity, I'm sure that some very clever scientists are working right now, but that's not what it is. And overall, if we treat the distinction between AI in the enterprise and AI, the rest of AI, I really like to say AI in the enterprise should not be an academic exercise. In the enterprise, it's basically the
Sure.
ability to automate a set of tasks that are more complex than a ruling system. So if you have
Mhm.
like a project like the one I was discussing before, like, okay, you receive some handwritten letters. You have to. I have a pretty disgusting handwritten and writing. So if someone has to read my
Guilty
stuff,
of that one too.
they're
Guilty of that one too.
gonna take forever, right? So it's building a ruling system, but a smart ruling system that can be then automated and overall remove a lot of the burden that us human would have to do otherwise.
Mhm.
That's how I would define it.
Yeah. I would define it much the same way. It's like, how do we automate a lot of the mundane? Or how do we
Yeah.
help you understand what's important? right? So to me, when I'm talking about AI in the enterprise, I'm thinking primarily of those two things. And that graphs on this concept of, well, these are just things that we would automate, but they typically take some sort of human intuition. I make the distinction kind of between our overall general machine learning versus when we're looking at kind of the fancy AI models, is when we're doing things with the AI models, the neural networks, they tend to be much more I don't want to say esoteric, but very much more complicated. They take more of what we would consider a human intuition versus when we're doing a classic regression problem or a classic k-means clustering algorithm.
Yeah, yeah, no, clearly, and otherwise, like overall, AI can deal with a lot of, especially if you manage to have like some very rich data, some fairly complex data, but it will only work in a well-defined environment, and
Mm-hmm.
you need to be quite explicit as what you're expecting into those boundaries. So essentially, what I'm trying to say here, it's very tempting to look at AI to solve some super complex use cases and super complex problems, but then stay in the realm of the academia once again.
Mm-hmm.
And in the enterprise, you really want to resist that temptation. Yes, it looks complex. Yes, you have complex data, but ultimately, it's on you, data scientists, to behind that there is an actual business question that has to have an answer. And the answer is not necessarily, do I have the best metric possible? Did I use the fanciest machine learning technique? That is not the answer. The answer is, me, I'm from the business. Do I save my customer better now? That's the only
Yeah.
way you should look at it.
So that actually brings up a great point, and we would love to hear how do you explain AI to anybody in your organization? If you're interested, please drop us a line on LinkedIn, drop a comment on YouTube. I will also make a big plug here for Hillary Mason, who is one of what I would consider kind of the pioneers of data science. She had a great sit down. Basically explaining machine learning and AI to 5 different levels of people. That was on Wired. We'll put a link in the YouTube and LinkedIn so you can get to that. But that's a great way to kind of understand what's going on in this world. So, Alex, we typically do this compare and contrast. I want to take this a little bit differently. When we're
Yeah.
talking about models, the alternative is really no models, right? So, what compare and contrast what we might do with a really fancy neural network model or a convolutional neural network model or a GAN versus the alternative. So, what's out there?
Yeah, like ultimately, data science and AI made such a splash that it's tempting to think that, oh, there's no alternative. Like if I don't have the most amazing random forest or the craziest variation of gradient boosting trees, then I cannot give an answer to the business. We have just simply forgotten what we used, I don't know, 10, 15 years ago, which was a rule-based system. And I'm not saying we should go back to rule-based system, but the answer is probably in the middle. The good thing with rule-based system at the time is it was 100% focus on the business knowledge. The business would come to you and say, I catch someone that is displaying some fraudulent behavior because of this reason, that reason, and that reason. And then on the statistical side, you would probably use Python to just validate those assumptions. But ultimately, you would end up building in one of those analytics platform a flagging and ruling system that would do something similar. Obviously, machine learning models are much better at building rules that make sense, that ruling system, probably do it much quicker as well. So you should probably definitely look into AI and data science. But once again, you want to do it with the core foundation of looking at it from the business first and shifting the conversation from that super rigorous academic exercise to what's ultimately valuable to the business. Because if you don't do that, well, what do you see? Well, the typical stuff that I see is the law of diminishing returns, right? Like data scientists are fighting so hard for that extra point of AUC. It's super
This
expensive
ain't
to
Kaggle,
acquire.
man. We're not trying
Yeah,
to.
exactly. It's Kaggle. It becomes Kaggle. They fight super hard. It's super expensive in terms of times from a resources perspective. But let's face it, like how many times have you seen that point of AUC sticking in the real world?
Right.
Yeah.
I have a great so Claudia Perlich, she is basically the head data scientist for Two Sigma. I met her a couple of years ago at a conference where she was giving a talk. And prior to her work at Two Sigma, she was in ad tech. So how do we basically build models that rapidly can decide whether or not to have to answer the question, should we buy this ad when Grant checks on this website, right?
Yeah.
The performance you need is under 0.2 of a second. You have to make a decision. So they had about 10 million variables, and 800,000 of those, basically we decomposed into make it easier for the model itself. One of the audience members is like, well, why don't you use a neural network, or why don't you use a more complex model? Because she was saying, well, we're just using logistic regression. And her answer response is like, you can't make it that fast. You can't score that fast.
What's the business problem? What's
Exactly.
the business problem?
The business problem is I have to make a decision.
Yeah, all the business constraint, the business context. And this is what I mean by really switching from, okay, I understand you have to do it rigorously. It's important. In data science, there is the word science. Normalize your data, all this kind of fun stuff, of course, but then do not ignore the real world. And as soon as you can incorporate the real world in what you build, then you realize that fanciness doesn't matter that much. And then you can focus on the real important things once again, which is business, customers, and avoiding okay, you have a model that works in theory, but then that can potentially create some problem like overfitting, and then the cousin of overfitting is potentially bias. And then
it's even So, when we even talk about medical, right? So they're in the medical industry, AI is super, super, super hot right now. But one of the issues that's had is the deployment of models into specific, or the ability of a model to generalize across different sites. And we're not talking the difference between Nigeria and the US, or Sudan and Singapore. We're talking about could be just a few, right across the street, or even in a different department.
Yeah.
So So for me, it almost becomes these end up becoming the starting blocks. So I see a lot of good organizations. Can we get value out of the model? Absolutely. But could we turn those into a set of rules? Will we be as accurate? No, because we're all along that efficient frontier of, high explainability, lower accuracy, lower performance versus more complexity, but lower transparency. To me, this becomes kind of that nexus point of the potential. So why can't I have both? Why can't I have a model that helps me find something but can be as transparent as possible? So, and that to me becomes, we'll hold off on our typical, spend money, make money, make the customer experience better, because I want to hold that one off to our next session here, because I think it's going to fall in very, very nicely. But what I really want to do, Alex, is what is the predictions here? because there is a whole lot of, there's a whole lot of promise, there's a whole lot of ambiguity, there's a whole lot of noise, there's a lot of hype. I mean, how do
Yeah, I
we
mean,
take the
it's
signal
not
from the noise here?
it's not like, first of all, AI is here to stay, right? We're not gonna go back to rules. We're not gonna go back to
We're not going to be
like
Luddites. We're not going to be Luddites.
no, that's done. And if we push the reflection further, um, the amount of papers that are going to come from the academia in the next few years is only going to grow and get bigger and bigger and bigger. And this is also going to find its way through the open source world, and all of those new methods, applications are going to be available in the enterprise. Ultimately, the enterprise are comfortable with open source concept. They realize that it's way less expensive to develop. It's kind of fine to to maintain as long as you have the right people. So yeah, like the academia is extremely active. That goes into the open source world, that goes into the enterprise. So that fanciness overall is always going to be around. It's always going to be there to stay. Now, what can tame the fanciness down is, and I hope at least that's the direction that people are going to go to, is AI is also going to be normalized over the years. What was fancy 5-6 years ago, now we consider that it's normal. And with the help of, once again, low-code platform, very easy to build some models, that remove the complexity and all the fanciness around it. And that helps you to focus once again on the business question, the business constraint, and forget about the method. The method can be handled by a software, it can be handled by a platform, it can be handled by a lot of different stuff. You can then refocus your time and your energy on the problem that you're trying to solve. So I think the fanciness is still going to be around. It's just going to be abstracted. You're not going to realize that, oh, somewhere behind that click, there is something extremely fancy happening.
Yeah, and I think that to me is that bifurcation of, there are going to be people going down that route, living in that complexity. But for the most part, I don't need to know how to build a car in order to drive it.
Exactly.
When we're talking about this AI, I need to understand the concepts. I need to understand the potential impact, but do I need to necessarily understand the complexity underneath? I'll give you a great story. So around 2014, I was working with a satellite radio company who, at that point in time, Spotify had bought one of their vendors that they were getting recommendations from. So every time you played their song, they were coming up with 3 new songs behind it. But you had rule sets, etc., because you got ASCAP and a couple of other different. You can't play the same artist more than 3 times in the same hour. You can't play 2 songs off the same record, right? So for them, they lost this. So we came in as a vendor, and we were basically, okay, this is how we have to build all of this together. We're going to bring all of this data in. This is, pretty cutting edge stuff. And I can remember when I started at Dataiku 3 years later. So this is 2017, 2018, or maybe it was just before I started. I went to a data science camp final presentations where a bunch of the students had taken, everybody's Spotify's playlists and built their own recommendations engine out of it. And I'm like, wow,
Okay.
okay, we were talking about $4 million deal at that point. Now you got a couple of, folks with $400 in credits from AWS now doing it. So to me, that complexity, it's always going to go down. The complexity may not drop, but the abstraction away from the complexity is always going to be important.
That's exactly what's happening. It's exactly this. It's like you're going to have, obviously the research is not going to stop, but what's not going to stop either is the ability to abstract that complexity and make it simple for everyday usage, ultimately.
And I think that's what's going to dovetail us into our next podcast, where, yes, we have some very complex models and they're fancy AI models, but what do I do if I don't know anything about them? Right? What are the questions I should ask of my machine learning engineer, my vendor, when it comes to this stuff? Because
Yeah.
ultimately, uh, the implementation of these models is going to become there's going to be a direct line of responsibility if it isn't already happening within your country today. The kind of AI model that you put out and the potential harm that it could do may have personal and professional uh,
Application.
implications for you.
Yeah.
So I think that's where we're going to leave it today on that little, that cliffhanger for next time. I appreciate that. So, Alex,
No
uh,
problem.
love the talk today. I'm very, very interested to hear feedback from the audience on this. Follow us on YouTube, follow us on LinkedIn. Tell us your comments. What are your predictions when it comes to, this big fancy AI model? What is it going to be in the enterprise? Do you think it's here to stay? Obviously, Alex and I do. We wouldn't be here if we didn't. But we're always looking for counterfactuals. What, and so for that, Alex, Hubert, thank you so much on this one. This is a
Right.
great podcast. I'm very much looking forward to this next one. And again, my name is Grant Case. Thanks for listening to the Proof of Concept podcast. Please catch us on LinkedIn, YouTube, or anywhere you get podcasts. So thanks so much. Have a great day.